We're going to continue with our Chapter 1 notes on page 8. And today what we're going to be talking about is another technique of factoring polynomials called factor by grouping. When we are given a polynomial that has 4 terms, remember terms are separated with pluses and minuses, so in all of these examples below you can see we have 4 terms in each one. So when a polynomial has 4 terms, it's not a binomial or trinomial, we are going to be looking to factor by grouping. In a factor by grouping, the steps to factor is, first of all, you're going to split the polynomial into the first 2 terms and then the second 2 terms. And I'd like you to draw a line. I usually draw a little squiggly line before the plus or minus operator on the 3rd term. The second step is you're going to factor out the GCF in each set of 2 terms. The first 2 terms are going to have its own GCF. The second 2 terms are going to have its own GCF, and you're going to factor out the GCF of each one, and what remains in both parentheses should be equal. And if they're not equal, then you can't do factor by grouping. So just put a little note. If they're not equal, you can't factor by grouping. Just a little note here. The third step is write what remains in parentheses. Remember, they should be the same. And then after that, you're going to follow it by the 2 GCFs, and they're going to go in their own set of parentheses. So what does this all mean? Well, when you take a look at number 1, you see it has 4 terms. And what I'd like you to do is draw a little squiggly line before the plus sign in the 3rd term. And you're going to have a first 2 sets of terms and a second 2. And each one of these should have its own GCF. So what we have here in these 2 terms, the GCF between x cubed and x squared is x squared. So let's just write this as x squared, this is for the first 2 terms, times what remains, x minus 4. So that's for the first 2. And then we are going to look at the second 2 terms, and the GCF in the second 2 terms is a positive 2. Whatever this is, you're going to write, if this is a plus, you're going to write a plus here. If this is negative, you're going to write a negative here. Now this 2 will have, or that's the GCF, and when you pull the 2 out of these 2 terms, you're going to be left with 2x divided by 2 is just x, and negative 8 divided by 2 is negative 4. So here we go, the first 2 and the second 2 sets of terms. And now what we see, that what we have in parentheses, they are equal. The x minus 4 is equal to this. So we say, yay, they're equal. That means we can do factor by grouping. Yay. So what we're going to do is write what remains in parentheses. Well, what remains in parentheses is an x minus 4. You write that once, not twice, because that's the GCF of these 2 terms. It's almost like having a term here and a term here. So here's your GCF, and what remains after you pull out the x minus 4 is this x squared and this plus 2. And that is it. You're done with that factor by grouping. And you could check your answer if you wanted to by foiling it. When you multiply FOIL, you will get back the original problem. In the second example, we're going to take the first 2 terms and write a little squiggly afterwards to the left of this subtraction. And now we're going to find a GCF in the first 2 terms. The GCF between 2x cubed and 3x squared is x squared. And then what we're left with, when we take 2x cubed and divide it by x squared, we're left with a 2x. And then you have a minus. And then 3x squared divided by x squared is just 3. So that takes care of your first 2 terms. That's the factoring of it, taking the GCF out. Now you have a minus here. So whatever this is, you're going to write it here. This minus gets rewritten right here, just like this plus got rewritten right there. So now what we have is we're going to try to find the GCF of a 4 and a 6, which is a 2. But what we're taking out is we're taking a negative 2 out. So negative 4x divided by negative 2 is a positive 2x. A positive 6 divided by a negative 2 is a negative 3. So when we're taking this negative 2 out of this 4x minus 6, in other words, we're dividing both by this negative 2, we're going to get 2x minus 3. And so now we can see that this 2x minus 3 matches up with this 2x minus 3. We say, yay, that means we can factor by grouping. So you're going to write the 2x minus 3 only one time in the front because it's the GCF of this and this term. And what you're left with is this x squared here and this minus 2 here. And that's the end of that problem. If you wanted to check to see if you're right, you can FOIL, FOIL this back, and you should get this original problem. So there's your final answer for the second example. On your third example, you have 4 terms. You're going to write a little squiggly to the left of this minus, and you're going to find the GCF between 5x cubed and x squared. Well, the GCF between these two terms is x squared. And if you divide 5x cubed by x squared, you're going to be left with 5x minus x squared divided by x squared is a 1. Now we have a minus sign, so remember you're going to copy that minus sign over here. This is a subtraction. And what is a GCF between 5x and 1? Well, there really isn't a GCF like there was for all of these other problems. So if you really don't have a GCF, you're just going to write a 1 because 1 is a factor of everything. And then you're going to open up parentheses and you're going to divide negative 5x divided by negative 1. This, or in other words, you're going to divide this whole thing out by the negative 1 that we took out here. And you're going to be left with a positive 5x. A positive 1 divided by a negative 1 is a negative 1. So what we have is the same set of the same binomial in both parentheses, so we can say, yay, we can do factor by grouping. If these were different, we could not. So we write the 5x minus 1 only one time, and what we're left with in parentheses is this x squared and this minus 1. And now we have a DOTPS, a difference of 2 perfect squares. So we can do one more step and finalize this answer by writing this as 5x minus 1, and then this factors into x plus 1 times x minus 1. And that will be your final answer for that problem. The last example, well, remember if you from yesterday's video, the first thing we're going to look for is a GCF. None of these had a GCF in all 4 terms. Well, this particular example has a GCF of 3 because 3 goes into all these terms. So let's take a 3 out first, and we're going to be left with x cubed plus 6x squared minus x minus 6. And so this is the one that you're going to be doing factor by grouping on. So you're going to split this up, and then you're going to, don't forget to write the 3. This 3 has to be written on everything that you do. And now you're going to take the GCF out. The GCF of x cubed and 6x squared is x squared. Let's open up our parentheses again here. So we have an x squared is our GCF here. And we are left with x cubed over x squared is just x plus 6. Now we have a minus here. Remember, if you have a minus here, you got to write a minus here. And because there is no GCF in an x minus 6, you're just going to put a 1 out here because 1 is a factor of everything. And if you divide this whole thing by this negative 1, negative x divided by negative 1 is positive x. Negative 6 divided by negative 1 is positive 6. And I'm going to double up this parentheses to get those two to match up. So now we have to write this 3 again. And we have this x plus 6 as a common factor. They're the same in both. And then we have the x squared minus 1, just like we did in the previous problem. So we're not done yet. We have a DOTPS. We have a difference of two perfect squares to factor. So we have one more step and then we'll be done. So we have 3 times x plus 6 times, you're going to factor this into x plus 1 times x minus 1. So the final answer actually has 4 factors. 1, 2, 3, 4 factors. And that's it. Now this last part says on your own factor the polynomials by grouping. So it would be really great, really please do this, shut the video off, please. And I want you to try these 3 problems on your own. And then after you get these 3 problems done, you can turn the video back on. I'll walk through all of these problems and you can make sure if you have it done right. All right, so shut the video off, please. And then turn it on when you're done. Okay, this first problem, we're going to split it before this minus. The GCF of 4x cubed and 4x squared is 4x squared. And what we're left with is 4x minus 1. Over here we're going to copy down this negative sign, and the GCF between these two terms is a 9. Negative 9x divided by negative 9 is just x. What did I do wrong here? Oh, I know what I did. Sorry, this is wrong. This 4 shouldn't be there. Oh, so just cross that out. Okay, so this negative 9x divided by negative 9 is just a positive x. 9 divided by negative 9 is negative 1. So now we have x minus 1's in parentheses. We write that out first. X minus 1 is the same. And then you're left with 4x squared minus 9. So we have a DOTPS again, difference of two perfect squares. So we actually have one more step to go before we're done. If you factor this, it'll be 2x plus 3 times 2x minus 3. So there's the final answer for number 1. Number 2, we're going to split this in front of the minus sign. The GCF of 16x cubed and 48x squared is a 16x. So if we take 16x out of here, we'll be left with x minus 3. Now we have a minus here, so we're going to write the minus down here, pull that same thing out. And if you divide negative x by negative 1, because there's no GCF between the x and the 3, we're going to be left with positive x and a minus 3. And now those two match, so we're going to write them out front, x minus 3, write it once, and then we'll be left with a 16x minus 1. And that'll be the final answer there. Oh, no, it isn't, because this is 16x squared, and this is 16x squared. And that is not the final answer because we have a DOTPS. So this is not the final answer. Good grief, what's wrong with me today? So we have x minus 3. The square root of 16x squared is 4x. We have plus 1 and 4x minus 1. So there is your final answer. Sorry about that. And then the last example here, we're going to split this in front of the minus. The GCF of 9x cubed and 18x squared is 9x squared. And we're left with x plus 2. We're going to pull this minus down, and the GCF of 4x and an 8 is a 4. Negative 4x divided by negative 4 is positive x. Negative 8 divided by negative 4 is a positive 2. So we have x plus 2's as the GCF. So we'll write that down. And we have 9x squared minus 4 is what's left over, which again is DOTPS, difference of two perfect squares. So we have one more step and then we're done. So we have x plus 2, and 9x squared minus 4 becomes 3x plus 2 times 3x minus 2. And that will be the final answer for that. So hopefully you got these all right, and sorry about that mistake in the middle. Have a great night.